G'day, it's Ben Holkin again from the School of Mechanical and Mechatronic Engineering at UTS, and we're in the vibration lab having a look now at the Siemens Simcenter scaleless mobile acquisition system, which you can see comes in this really lovely case box here, which is bomb-proof. I'm just going to talk through the stuff that's in here because there's quite a lot of equipment and not all of it might be immediately obvious as to what it is. So the guts of it is the acquisition system itself, or the scaleless mobile, which I've shown in a couple of previous videos, just briefly had a little look at it. Okay, it comes out of the box. Again, it's a very robust, ruggedized system. It's expandable, so these feet, for example, allow us to mount multiple, daisy chain multiple devices together if we want higher channel counts. This is the SCM05. There are 5 available slots, sorry, 1, 2, 3, 4, 5 on the front, plus the communication module, plus the battery module, and then some other spare locations for different variants of this device. On our device we've got a V8E, which is an 8-channel voltage and ICP, as they call it in PCB term, but that's basically IEPE, integrated electronics piezoelectric. So that's an 8-channel device. There are breakout leads, which I'll show in a moment. We also have the RV4 module, the rotational velocity, or rotating velocity 4-channel device, which includes a couple of, or either 4 extra tachos, so once per revolution tachometer measurements that have got 4-pin breakout cables, or you can have 2 incremental encoders. So you can select in software whether you're going to use 1 incremental encoder and 2 tachos, or 4 tachos, or 2 incremental encoders. And so this is somewhat aimed at rotation machinery measurements. There are also 2 inbuilt tachos on the communication card. There's also a CAN bus if you wanted to connect it to the vehicle, if you were doing vehicle measurements. We've also got 2 output channels here for example, experimental modal analysis. So these 2 output channels will drive a couple of shakers, for example, 2 uncorrelated sources. And an Ethernet port to connect it to the host PC, which the software is installed, and then power supply with a power input and also battery module. Press and hold to start. It will boot the system, press and hold to turn off. And it gives an indication as to the level of charge here, which you can see currently is not fully charged. Power supply is in the box over here. There's a bit of a big adapter. Plug that one into the mains, and we can connect the LEMO power supply cable into the acquisition system. And then you should see it start to flash green and amber to indicate that it's charging the battery, slowly flashing green and amber over here. In the box we've got 2 breakout cables for the incremental encoders that have been made at UTS for us and pre-wired by our excellent technical support colleagues. So you can use one or the other of those, and they're all labelled according to how you typically connect an incremental encoder to any kind of acquisition system. We also have an Ethernet cable to connect to the host PC. If you don't have an Ethernet port on your host PC, there will also normally be, although it's not here right now, a 10 gigabit Ethernet to USB adapter. So all laptops will have a USB connection, USB 2. You can connect it, and then we have a series of breakout cables, which I'll show you here. In fact, there's the Ethernet adapter. It is in here. So you can see there's a whole raft of cables in here, and I'll just work through what each of these cables is so we're all completely clear and we don't get them muddled up. This LEMO connector that's got a single pin, you can't probably see it in the video in the end, is a breakout cable for one of the measurement channels on the V8E. Okay, so that just goes to BNC in the same way that an oscilloscope has a BNC input, and then we can just connect into our BNC with any type of normal cable, which might be like this, microdot cable, or might be a regular shielded BNC cable. This is for CAN connections, so we don't typically use this. This has got 4 pins inside, but the thing that gives it away is the 9-pin D-sub, which would be what you connect into your vehicle. So we'll put that one back inside the box for now. Obviously there are 8 of these breakout cables for the 8-channel V8, so I can ignore most of those. This connection here is for a tacho. So this one has got 4 input pins inside the LEMO connector, but it's also got BNC on the output. Okay, so this is one of the tacho channels, and obviously there are up to 6 tachos, so there are 6 of these, well there should be 6 of these cables. Can't quite count 6 on there at the moment, but maybe there are only 2 and we didn't get the extra cables. If you find a cable in here that's got 4-pin LEMO on one end and 2 breakouts or 2 BNC connections, this is the 2-channel output cable. So this one goes into the output cable over here, the output connector over here, and this would give us 2 uncorrelated sources to drive 2 shakers separately, and those are controllable in software. And that, I think, should be it in terms of breakout cables. There are a couple more cables in the back here that are not necessarily often used. So there's a power cable for in-vehicle measurements that we made up, again here at UTS, I believe. So it goes to a 12-volt car cigarette lighter style socket. There's also a cable here that is kettle lead, essentially, an IEEE standard lead that allows us to connect from, for example, the PSV acquisition system frame into the power supply, so that we can take power from the PSV instead of from the mains. And I think that pretty much wraps it up. Thank you.